Welcome back to the Industry 4.0 and Sustainable Supply Chain stage here at CogX. They have been some absolutely amazing, brilliant sessions today. And I think the next one's going to be even better still. So I'm Katy. I'm the CEO of Beep and founder of Frontline Live. And I'm your MC on this stage for the next couple of days. On a second, I will hand over to Kadine James, who will lead the next conversation, which I'm really, really excited about. So over the last couple of months, I've convened 40 volunteers and built the very first ever decentralized national map of real-time PPE needs from the frontline healthcare workers. So I've learned a lot about the supply chain and how it can be improved. One of our partners is 3D Crowd, which is 8,000 people across the UK who have been 3D printing masks and getting them, about 30,000 of them every week, to the front line as soon as they are needed. It's such an amazing story. So this panel is about how do we build resilience into supply chains, especially now in the midst of the COVID pandemic. So massive pleasure to hand over to you to Kadine James, who is the creative tech lead at Hobs and the UK lead of Women in 3D Printing.
Hi, everyone. I'm delighted to be here. Thank you for that wonderful introduction, Kat. It's a huge honor to be here at CogX. Welcome to the Manufacturing a Better World stage here, and how additive manufacturing may be bringing about a revolution. I'm going to be moderating the conversation here at CogX, and I wanted to thank the brilliant team at London and Partners and the wider CogX team for making this happen, and for you and to you, the audience, for joining us today. What we're going to do is have a conversation with leaders from the additive manufacturing industry, and I'm going to invite them in to introduce themselves in a moment. You can follow us on social media, and I'd love for you all to take part in an activated conversation that's inclusive. So please do follow us and tweet comments and suggestions on social media. My name is Kadine James, and I'm the creative technology lead at Hobs 3D. We're a digital foundry and XR, VR, AR studios based in London at the Olympic Park. It's a huge honor to be here with many of the world's forward thinkers, artists, activists, and policymakers, especially during this time of a global health emergency and with racism, injustice, and the climate and ecological emergency making us all responsible for what comes next in the next 10 years. COVID-19 has been a test on society, of our governments, of communities, and of individuals. It's a time for solidarity and cooperation, respect for human rights across the spectrum, including digital rights, economical, social, cultural, civil, and political rights, all of which will be fundamental to the success of the public health response and the economic recovery to the pandemic. The impact of the coronavirus has been immediate and dreadful. The 3D printing industry and our digital manufacturing partners around the world have been working non-stop in the battle against this hideous virus. Rather than building walls and drawing up bridges, we have been collaborating across borders. The additive manufacturing community have been working on several fronts to respond to the global pandemic, from developing certified medical devices to help patients, to protective devices for healthcare workers, which includes getting PPE into ICU settings. And I've been involved in a number of those campaigns with both Hobs and with the Shield Collaborative and the Doctors Association. Additive manufacturing is set to revolutionize the industrial production chain for the 21st century. And I wonder what the role of the AM industry might play with regards to sustainable solutions, sustainable materials that leave a lighter footprint on the planet, and how we can ensure that we use the technology for good. How can we make the industry more diverse and inclusive? And what will be the type of design skills that we will need for the industry and the COVID generation? Today, I'm joined by Milne, who's the Chief Engineer at Drama, the Manufacturing Technology Centre, which is based in Sheffield. I've also got Josh Mook, who is the Innovation Executive from GE Additive. And we've also been joined by Anthony Graves, who's the Director of Product and Digital Manufacturing Software and Data at HP. Katy, I'm going to ask you to introduce yourself and tell us a bit about the work that you're doing at MTC.
Hello, thank you so much for having me. Just a slight correction, Kadine. MTC is outside Coventry, and since Coventry is often a much underrepresented city within the UK, I just wanted to correct that. But,
thank you, Katy, for my geography lesson.
Okay. One of our partner centres, the Advanced Manufacturing Research Centres outside Sheffield, and they help companies in their area, but across the UK in a similar way to MTC does. And we're part of something, both centres part of something called the High Value Manufacturing Catapult. So the High Value Manufacturing Catapult is a cluster of research centres in the UK, funded and supported by the UK government in our mission to help UK manufacturing. The MTC is one of the centres in that cluster outside Coventry, and we're also the home to the UK's National Centre for Additive Manufacturing. And I'm part of the team there, leading a large supply chain programme called DRAMA, which is a £14 million supply chain programme supported by UK government, part of their Industrial Strategy Challenge Fund, funded by Innovate UK and part of the Aerospace Technology Institute programme. It's led by us, and we're working with a number of different technology providers, and the project's got two faces really. We're trying to give pragmatic advice to companies who are looking to adopt metal additive manufacturing. That's the scope. The National Centre looks at all additive, but I'm particularly interested in metal additive. So the adoption of metal additive manufacturing by aerospace companies, and trying to really generate a wave of adoption within the UK through that kind of simple pragmatic advice. That's on one hand. And then on the other hand, in the programme, we're looking at the digital thread and how digital tech can enable people going faster to market with additive manufacturing. We're working with Autodesk and ATS Global, Rennie Shaw, I'm missing somebody, and ANSYS Grantor on that activity. So that's me.
Brilliant stuff. Thank you so much, Katy. I now want to bring in Josh Mook, who's doing extraordinary things too. Josh, tell us about you and the work that you're up to.
Yeah, so my name is Josh Mook. Thanks for having me today. So I'm at GE Additive as the innovation leader there. And really what I focus on from a day-to-day is what are those next generation, equipment, modalities, what are the new designs that are going to be enabled by additive, and how do we help bring those into reality for not only ourselves, but for all of our customers and partners and collaborators. And so GE is sort of unique in that we're one of the biggest users of additive in our designs, and we'll talk about some of those as we go on. But that really pushes us to develop better equipment, better processes, better in future modalities that are going to allow additive to move beyond the laboratory. And really our goal, simply stated, is to make it commonplace in the manufacturing environment. And we believe that it offers some really unique advantages when it gets there.
Fantastic. Really looking forward to hearing more about the better equipment and better products that you're working on there at GE. I'm now going to bring in the brilliant Anthony Graves. Anthony, tell us about the work that you're doing, and where are you actually? Whereabouts in the States are you?
Just outside of Charlotte, North Carolina. Thank you so much. As a matter of fact, tomorrow is my 1-year anniversary with HP. 3D print and digital manufacturing. So
happy anniversary.
Thank you. It's really exciting. HP, it's a brand that most of us have grown up with, especially in the engineering community. And I've followed them mostly through their work with workstations and mobile workstations over the years. When they launched the 3D print division, I was really excited to see what they would do, what they would bring to the market. But what intrigued me, they reached out to me just over a year ago, and they talked to me about a a vision that they had around digital manufacturing. And shortly after I joined the company, after they convinced me that they had a really strong vision, and they identified some opportunities in additive that I think would complement the work of everyone else, certainly not only in this meeting, but everyone probably watching. And it was a month later, I was at an event for a rollout of a new series of printers from HP in Palo Alto at the headquarters. And one of our executives, Christoph Schell, mentioned to the media, he introduced himself, and he said, don't be surprised if the name 3D print and digital manufacturing changes to digital manufacturing over the next 12 to 18 months, because that's really our vision. It's not just about printing, it's about the whole ecosystem. So when you reached out about this talk about supply chain, I don't think today you can separate, you cannot separate additive manufacturing out from any conversation of supply chain. With COVID, it obviously exposed a lot of the limitations with existing technologies in the supply chain. And additive, if there was one bright story to come out of this whole experience, it's been how additive can be leveraged to complement and supplement supply chain in times like this. So I'm excited to be with all of you today and have this conversation.
Thank you so much, Anthony. It's great that you were able to join us, and the power of technology that's allowing us to have this global conversation, especially during this time of a global health emergency. I'm really interested in starting actually with Kate and hearing about the kind of new designs and innovations that are taking place within the MTC, and how we might be able to leverage that between the manufacturing communities here in the UK that haven't adopted rapid prototyping or additive manufacturing workflows. What can we do to support those individuals and businesses here in the UK?
So on the one hand, at MTC, we've been working with some of the aerospace primes and tier ones on their products. Their strategy, I mean, perhaps General Electric are better to talk about this, but this is my perception as someone not within the primes. Their strategies have been different. So the propulsion people and the people who are making systems components seem to be going for very high risk stuff, where there's this kind of combination of lightweighting, better performance, component consolidation, reduced volume. You know, it's just like tick, 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 tick. So they've been going for it. But on the other hand, we've got the structures companies, so people like Airbus and Boeing, who've started on a strategy I perceive of more component replacement. Because the things are bigger, the airframes are bigger, they're also often looking at different technologies. So propulsion systems have been very much focused on a process called powder bed fusion, which is where you have a bed of metal powder, and you melt a layer, then add a layer, then melt a layer, then add a layer. You can normally print things that are kind of shoebox up to 0.5 meter cube. But in structures, they're also looking at larger format systems where you've maybe got a robot head and blown powder and you're depositing it. So there's kind of different strategies. But what's really interesting is to see the rate of adoption beginning to pick up now. I think we're around about 30, 40, 50 components certified, but the investment that's being made in R&D in aerospace is hefty, or has been up until COVID. So we'll see how things pan out over the next few years. But they really see it as an enabler for lightweighting their platforms, but also getting new performance. And I think it's going to be really critical in terms of the adoption of new aviation products, by which I mean, at the moment, aviation is based upon fossil fuels, very old-fashioned structures. And we've got this big wave of startups and incomers, competitors to people like Boeing and Rolls-Royce, disruptive companies now looking at urban air mobility, vertical takeoff and landing, hydrogen fuel, biofuels, and how that all pans out, how the big companies begin to work with these small disruptive companies, and how additive can enable those new products in terms of, you know, more integrated cooling, lighter weight. That's really interesting, I think, to watch in the next 5 to 10 years.
Yeah, absolutely agree with you. I think the startup community are doing extraordinary things, and I think that's a really valid point. I want to bring Anthony in now. You spoke a bit about the vision for AM and your vision when you joined HP. Can you talk a bit about that vision and what that looks like, and particularly what your plans are in response to COVID and the technologies and that you're using, and how they're going to benefit the world?
That's a simple question. So the focus, I think, for HP, once HP said we're going to get into additive manufacturing and we're going to get into 3D printing, like a lot of other companies before them, and since you're in the UK, I'll tip my hat to Renishaw, one of the leaders in metal additive. They quickly realized that something that all of the other additive companies realized, and that as impressive as a lot of these processes and technologies are, there's no one technology that is going to fit the bill for every product that's created and every solution that needs to be invented. So you're part of a larger ecosystem, and as soon as you recognize you're part of a larger ecosystem, then you have to start to design with that concept in mind, and not just connectivity between devices and things like that, but looking at the broader picture. How do you connect other devices into your system and vice versa? And so we have a lot of strong partnerships. Katy mentioned earlier partnership with Autodesk. We also have a strong partnership with Autodesk. Matter of fact, I have a call with them in 2 hours. We also have a fantastic relationship with a company out of Belgium called Materialize, as well as Siemens, and others too, Link 3D, AMFG, 3Year Mind, and a bunch of other additive specific companies you may have heard of, AMFG being in the UK as well. And so it's how do we help drive the conversation using our experience as a major manufacturer with a huge supply chain, and how do we work together to solve a lot of these problems? And so HP is known for innovation and inventing. It's in our slogan. And so one of the things that we're trying to do is look outside. There's been a mentality, I think, for decades about, is it invented within the company instead of is it invented in partnership with other companies? And I think the future, and it's pretty obvious, that the solutions and the technologies that are going to advance are those that are worked on together. So for example, the 3MF consortium has a bunch of companies in additive and digital manufacturing at large that have come together to help develop a standard around a 3D printing file format. So HP, I would just say, has gotten more involved in a support role, and even in a leadership role in a lot of the organizations that are starting to define what Industry 4.0 really means, and what digital manufacturing should be. Digital manufacturing has been around for 30 years. As soon as we had computers and people started networking, I've been in the industry myself for a long time, and I run into folks that are retired now, and they get frustrated when they hear that digital manufacturing is a new concept. And folks from the old ERP days and the MES days and CAP days, and I get it. But there's a tremendous evolution brought about by the internet, and there's been a tremendous evolution brought about by additive manufacturing processes. So I don't want to say it's any one thing. We're obviously developing solutions. This fall we're going to have a launch of some new products around digital manufacturing. And if there's one word that I would say that HP is focused on right now, and that's universal, making sure that we're part of the whole ecosystem, and we're not creating walls around our technology that make it impossible for companies to work with all of us.
Yeah, that's really interesting. And particularly, I want to lead into the connectivity between devices and the work that Josh will be doing in that space, particularly how other technologies are working with additive manufacturing, including artificial intelligence, 5G, VR, AR, mixed realities, and HoloLens technologies. Josh, can you tell us a bit about that?
Yeah, sure. So, I mean, as was mentioned previously, the lines are blurring between manufacturing and design and the consumer in a really important way. And it's changing also the entitlements on how the equipment has to work and what it needs to be in manufacturing. Manufacturing is no longer a dirty, kind of the days of the past, if you think about it, right? That's where we like to refer to Industry 4.0 and even beyond that. And so today's workforce, also the workforce entering the manufacturing space, has different levels of assumptions on how things work, right? They've grown up with a different level of connectivity and access to information than ever before. And our equipment has to reflect that if we want to enable the type of productivity advancements that we want. And I would say, if you think about additive manufacturing specifically, it changes the entitlements on design so much, and it weaves itself into the fabric of how components are designed. Earlier we talked about things like new energy efficiency entitlements or new durability entitlements, or even what does manufacturing footprint look like in the future. We believe it's very distributed and close to the source of consumption. In those type of environments, you cannot assume that you're going to have a dedicated, highly knowledgeable workforce in a certain area, and therefore our equipment and our software and our processes have to evolve to enable that. And that's a big focus for us. If you think about our new factory equipment that's coming out, it's really around lights out manufacturing in a way that is modern, in a way that is attractive to the new generations, in a way that offers new cost entitlements for the companies that deploy it, so they can go after potentially products or advancements that they never could before. And so I don't think you're going to be able to distinguish those boundaries in the near future. All these technologies are really converging in a really impressive and dramatic way.
Absolutely. I want to also touch on your comments regarding Industry 4.0. What about Industry 5.0? What will be the skills and attributes needed by the next generation, and indeed the existing workforce, in order to navigate what is a very uncertain world? And I wondered what you're doing in and around that.
Yeah, so, to touch on that a little bit, if you think about the next generation of workforce, what we have found, at least within GE, is that the students straight out of school are much better positioned to adopt additive than even some of the incumbent workforce that is maybe even more familiar with manufacturing. And that is akin to the Industry 5.0 revolution, right? We are centralizing information in a way that really allows that access across the board. In addition, when you think about things like robotics, if you think about Internet of Things, if you think about the machine connectivity, there's no generation better to leverage that technology than the ones just entering the workforce now, or the ones that will be entering the workforce in the future. I think the other thing that's really interesting that I want to highlight from a workforce perspective is we are breaking down barriers regarding what are the cost productivities that low-cost labor provides. Those are really starting to dissolve. And you can now think about distributed manufacturing in a way that is economical and is accessible regardless of location. So now you're starting to think, how do I make manufacturing local? How do I make consumption local to that manufacturing source? And that's a big push for us as we think about Industry 5.0 and incorporating it into new ways into our ecosystem.
Yeah, it's really interesting. I think that the skills challenge that we face here is, especially in the UK, is a significant one, and I think that lots needs to be done between industry collaboration, working with academia, working with young people, and looking at ways that we can really build a bridge to address the digital skills gap. I now want to bring in Anthony to talk a little bit about data and ethics. You head up the kind of data side for HP and also the AM and design process. I'm interested in what your thoughts are around data rights and data ownership, and what we might be able to do in order to kind of regulate that.
Wow, you know, there are a lot of companies that have just popped up over the last few years trying to address this question. It's an important question. Obviously, data privacy and privacy in general is a huge topic around the globe, no matter what industry you're talking about. When you get to, when you take it out, like Josh was saying, to the customization and personalization end of Industry 5.0, then that becomes a critical part of any discussion. The ownership, for example, of a design. Who owns that? When you customize a pair of shoes, when you customize anything, like it could be a phone case, and I always hold up my phone case as an example. Who owns that design? If you're generating that design in a tool online through some front-end e-commerce type solution, or you design it yourself and you upload it to a service, what are the terms of service around that IP? Because you're creating IP. It's no different than writing a song. You're creating a piece of art, and so potentially, or fashion, right? So it's really interesting. I would say one of the things that we're doing is working with a lot of these companies, because there are technologies that are emerging from companies like Leo Lane and Authentize that are designed to help protect the data and the ownership, to be able to identify who the owner of that data is, all the way through the manufacturing process, up to and including creating capabilities that can be deployed on 3D printers and other industrial equipment that respects that chain, that ledger, blockchain, if you will, and ownership. That's just one huge aspect I see moving into the future. Now, on the other hand, with a younger generation, and I've had conversations with folks at various universities about this question, about, do people even care about owning things like that? If it's music, they very much do. But if it's customized, in the case, coming up with your own textures, using technologies like generative design today. So I think it's a huge subject, and I don't think we've really begun to scratch the surface. It used to be DRM. It's evolving much more into IP, individualized, personalized IP, and how that's going to be respected in this new manufacturing supply chain, whether it's distributed or it's local or it's individual in someone's home copying someone else's design. So it's an interesting topic.
Yeah, I think it is, and I think we need kind of better policies and procedures and regulation, particularly around the kind of the big tech companies that are out there. But that's a whole other story that we can go into another time.
Sure.
I want to bring Katy in now. We obviously both do a lot of work around equality, diversity, and inclusion. We need to bring more girls and more women into the additive manufacturing space. And I'm going to ask that question to Josh and to Anthony. I want to hear about the good work that you guys are doing at HP and at GE. Kate, what do you think about this?
Well, crikey, that's a really big question. It's the United Kingdom's got about the lowest proportion, or one of the lowest proportions of female engineers in the world, and I'm not quite sure why. I somehow think it's a hangover from maybe war times, when we had loads of female engineers and then the men came back from war and we were boosted out of those jobs to make space for them, which is very understandable. But somehow that's very entrenched in UK culture that women shouldn't do engineering, whereas in other countries, you know, like Eastern Europe, South America, will be 30-40%. I think what's quite encouraging is that the proportion of women to me, and I have no stats on this, maybe you do, Kadine, for in 3D printing seems higher than in other areas, for instance, mechanical engineering, which is where I've studied. And I think the reason that is because people can see two things. There've been studies which have shown that women really want to feel a direct impact, you know, in terms of the work they're doing. And some of the stuff in 3D printing, the impact's so direct. The PPE example for COVID, a good one, but also things like Open Bionics Hero Arm, you know, the 3D printed bionic arm. It's just incredible. And so I think that can draw women towards it. But also it's quite a creative space. So like girls, I don't know if it's indoctrination from when they're kids, but girls often have this thing, I want to do something creative. I actually think all engineering is creative, right? But additive is certainly an area where it feels more obviously creative. And so I think it's naturally a space for women. I think we've just got to work harder at bringing more people in and including the guys, because like they're amazing too, you know, and all my best teams have been mixed ones.
Without the guys, we're not going to bring about any change. And on that, I'm wondering what Josh and the team are doing at GE to kind of bring more female voices, more diversity, more inclusion into the additive manufacturing industry.
Yeah, absolutely. So a couple things maybe to kind of reference there. Number one, additive is still relatively new technology, right? There's not an incumbent workforce here that we have to go disrupt. I mean, I've got 10 years of experience in additive and I'm an old timer, right, in this space. And so think about that. First of all, there should be no barrier there. Number two, to really get the maximum advantage out of additive from a design perspective, you need diversity. You need diversity of thought. You need it across the board, because no longer are the days of understanding how to, you know, machine things and that sort of generational knowledge that you would see from like a master machinist, for example. That doesn't matter anymore. So we really need diversity of thought. From a GE perspective, you know, a thing we really believe in is getting early on the education program. So if you've heard of our education program, you know, we distribute both polymer and metal printers globally to schools, primary all the way through secondary, as well as universities. And that's been a powerful impact, not only just the distributing the hardware itself, but also the curriculum, the setting up clubs, making sure the teachers are empowered. And I'll give you a great example. In Cincinnati, where I am now, there is a girls 3D printing club that's in a primary school. And the work that they're doing is absolutely amazing. I mean, I would argue that they're better at 3D CAD than some of my engineers are, and they're, you know, 7 to 10 years old. And so I think what we're going to see, if we continue to foster this in additive and we continue to really accept and push education, I think there's a great opportunity to have a diverse and equalized workforce.
Yeah, no, that's great. It's really important. And I think that we all need to work together to bring about those changes. I also wanted to touch a little bit with Anthony now on materials science. And obviously we have a climate and ecological emergency that's happening around the world. What can the additive manufacturing industry do in terms of materials science and ways that we might be able to leave a lighter footprint on the planet?
Sure. Well, one of the advantages of additive is the fact that you can eliminate waste, a lot of waste. Now, I know that in CNC machining, traditional subtractive manufacturing, which is the world that I originally came from way back, you take all of that scrap and then it gets sent off and processed and it's recycled. So there is a misconception about how much waste is generated through some of those traditional manufacturing processes. But additive really does allow you to, I believe, design in a much more green way, like what Josh was saying earlier about the design, because of the ability for additive to produce parts that could not be produced otherwise with traditional methods, whether it be CNC machining or fabrication. or taking traditional designs and lightweighting them, especially in aerospace and automotives where weight is critical, and you can only achieve that through additive processes to the extent that you can with additive. Inherent in much of those processes is just a process that doesn't have as much waste and it uses less energy. And I think in the creation of the materials as well, I know with the material companies and partners that we have, like Evonik and BASF, I know that a great amount of care goes into and thought goes into when they are designing these new materials. What is the reuse? How much can we reuse these materials? As a matter of fact, well, there's some exciting news coming out this fall. I don't know if I could talk about it, but
please do.
I know.
We want to know.
I'm like trying to think, oh my gosh, can I say? But let's just say that reuse is going to be key. I see a future where there are going to be materials where you're going to be able to get 100% reuse out of it. That's pretty incredible. Yeah. So one of the neat things about additive, if you want to call it neat, I do, is that the technology really is green almost by default. You have to use energy, obviously, everyone knows that. But I think that one of the happy outcomes of additive technology was the fact that there is a great deal of care spent on the use of energy, minimizing the use of energy, and the reuse of materials as well. Now, I will say this. Other companies, HP certainly has some exciting materials. I brought a 3D printed part. I had it with me, and it shows some of the flexibility and color flexibility of industrial thermoplastics. So we have a number of different nylons and some pretty cool materials that we have. But if you look at some of the other processes as well, with metals, I don't know. Josh would probably be able to give you a better answer than me, but I know of at least a couple companies that are doing 4, 5, 6. One company doing 10 or 12 different metals on their machine, which is pretty remarkable. And then on the other hand, you have some plastics processes that are showing some incredible results. So with textures, where you used to have to compromise or sacrifice between the cosmetic look of a part or feel of a part and the durability, the mechanical properties of a part, you don't have to make those sacrifices anymore with a lot of materials. So that's where we've certainly seen one of HP's markets being companies that are looking for that really fine detail, but with a really robust, durable part. So material science, if you were to look around, one of the stories I think that maybe outside of material science circles doesn't get a lot of airplay is material science. It's huge. I know in HP, one of our senior executives is a material scientist. That is their position. And I know that's true for a lot, if not all of the other additive companies. Material science is like right at the heart of what everyone is working on. And when you talk about digital manufacturing, one of the interesting things about additive is that there's a lot of not just product development, but process development. Because even though Josh says, he's been around 10 years and he's a veteran, and it's true, you've been around that long, you're a veteran in this industry. But what's exciting is that all these technologies are unleashing new potential with existing additive processes. And the only way to keep track of all of it is through this process development, where you're tracking all of the different variables of the materials. And that's where you have material science merged with data science, going back to one of your earlier questions. Mm-hmm. And that's one of the things. We have a data scientist who's over our data science project. Our group is called Software, Data, and Automation inside of digital manufacturing. And it's a huge part of what we do is take a look at the granularity of information and data that follows the additive manufacturing process, from sensor data to material data to test data. It's really exciting. And I just want to mention, we have an intern program like most companies. And in my particular group, in the data group, we have 2 students from MIT, female students. And I was surprised because manufacturing is traditionally a male industry because it was a lot of brute force and moving heavy metal around and, turning wrenches and things like that. Additive manufacturing has flipped that on its head. I have not been, I haven't been to a facility where there aren't a tremendous number of women. And inside of HP, I don't know exactly what the numbers are, but in very important leadership roles, women hold the majority of the positions. And they're certainly, they're role models in the communities that they exist in, and HP participates in a lot of women in technology programs. So I think additive is enticing because, again, like Josh said, manufacturing used to be thought of as a dirty industry, which it wasn't. Maybe 50, 100 years ago, certainly it was dirty, but additive is thought of as clean, so it's approachable. And I also think the creativity that women bring in to other industries that additives made possible, like fashion, that also is another reason you're seeing an influx of not only women who are engineers, but are also artistic and creative.
Yeah, and I agree. I think, women throughout the history of time have proven that they can do just about anything that they set their minds to.
Oh.
I'm delighted to hear that.
Better than guys.
Good work there, and really brilliant stuff that's happening at HP. I just want to kind of have some kind of last comments on the space race. Are we going to be living on other planets? Is 3D printing going to take us there? I'm going to ask that question to Josh, and then I want Katy to come to that point too. Josh?
Yeah, I mean, absolutely. So, if you think about the space race, I mean, additive is a mainstay in space already, specifically metal additive, but also polymer additive, right? You may be surprised the launch that NASA and SpaceX just did, how many parts were on that in many different ways that were additive manufactured. You're seeing it in our aerospace as well. So, but to your point, if we're going to live somewhere else, whether it be in space or on another planet, to your provocative question, it makes so much more sense to ship a material that can be turned into anything than ship something, in a very expensive and difficult way that is single use, single purpose. And so no doubt, if there's the manufacturing that's going to occur outside of this planet is going to be additive manufacturing. Absolutely.
Absolutely. I'm really interested in the work that Relatively Space has been doing. There's a brilliant materials scientist there, Eliana Fu, who's doing extraordinary things. Kate, I just want you to speak to that comment, particularly on what you're doing in the aerospace sector as a leading engineer and somebody that I'm really inspired by. Kate, what are your thoughts on this?
Well, I work more with aeroplanes, but it's like one of the disappointments of my life because I got into engineering because I love space. I'm a super geek. I went to space school twice when I was a kid, like band camp, but for space geeks. Anyway, but one of the things that just occurred to me, we're the European part of the European Space Agency's benchmarking centre for additive manufacturing. We do a lot of work with aerospace, Airbus Defence and Space, and other players in the space industry. And as Joshua said, it's an incredible enabling technology because of the lightweight potential, the material freedom that Anthony was talking about. But one of the things that just struck me was the link between we've got to get to space, we've got to potentially take our materials or mine our materials on the journey, and the situation we've just been in with COVID. Because what happened with COVID and suddenly having to manufacture more bits locally was that 3D printing provided a very short-term solution. We can take some of the existing feedstock that we have around us and use it to get going. But that feedstock began to run out, and we then had that problem to face. Like, what are we going to print with? And it wasn't just printing; it was other manufacturing processes. But in terms of supply chain resilience, that really brought home to me that we need to start looking back. They talk in the food sector about farm to fork. We need to look back to the mine and think about how can we make printers that can print with more stuff and print with more freedom, you know, and taking different materials, and how do we integrate the pre-processing of those materials, and how will that enable us going into space?
For sure. It's a really valuable point. I'm conscious of time. I just want to remind that the audience out there, please contact us. We've got some of the best minds in additive manufacturing here with us. Please send in your questions. We really want to hear from you. I'm just going to go around now and just want closing remarks. And I'm going to start with Anthony. Anthony, additive manufacturing, last closing sentence. How's it going to change the world?
It has. It already has.
And for the future, what are your kind of predictions?
Well, I'll tell you what. It's. I think Katy hit the nail on the head, and also going back to what Josh said about being able to produce what you need with the materials around you locally through distributed manufacturing. That's where I think you're going to start seeing some of these ideas become refined.
Yeah.
And additive is the only technology that really makes it possible.
Yeah, for sure. Josh, final remarks?
Yes. Yeah, absolutely. I think additive is going to become commonplace. I mean, we have a saying within GE, additive is here, whether you accept it or not. You're either going to become, a user, an expert at it, or you're going to become a victim to it. And I think we are at a turning point right now where companies and folks have to sort of decide to jump on the next wave or be left behind. And that's just the reality.
Absolutely. Katy, what are your closing thoughts on this? And then we're going to look to wrap up and invite everybody in for a Q&A session. Katy.
I think additive nowadays feels like it's got a lot of momentum. I think people thought maybe it wouldn't happen, that it was it was hype, but it's going to happen, I think. And as Josh said, you've either got to get on that bandwagon or potentially be left behind. But the community is very driven, very excited, and I'm just keen to see what happens in the next 5 to 10 years.
Yeah, it's fantastic. And Katy, is that a 3D printed horse I can see in the background?
Yeah, it is. Well, electron beam melting, so thank you from General Electric Arcam. It's beautiful.
I love it. I had myself scanned by the Veronica scanner, the Royal College, a number of years ago. I've sent this to every member of my family because they all need an extra version of me in their lives, which is debatable. But I'm honoured that we've been able to have this conversation. You're all extraordinary, doing really incredible things, and I'm just delighted that we were able to take part in this CogX conversation. I think the additive manufacturing is just going to continue to evolve. I'm really interested in how we're going to use the technology for good, how we're going to have an impact, particularly around the climate, particularly in response to future health pandemics and emergencies. And it's been a huge honour to be here with you all. So thank you.
Thank you.
Want access to more CogX videos? Subscribe now for free at cogx.co.